Hello, my dear children, and welcome back. I know your exams are just around the corner, and for many of you, three-dimensional geometry can seem a little scary. But I promise you, by the end of this session, we're going to make this chapter your new best friend. Let's make it super, super simple together.
So what's on the menu today? Here's our simple plan. We'll start with a line's direction. Then we'll give that line an address. After that, we'll see what angle two lines make. Then we'll tackle the shortest distance. And finally, a super fast revision of all the formulas. Simple hai na? Chalo, let's start.
All right, first things first, the absolute basics. How do you even describe a line's direction in 3D? I mean, it's not just left or right, up or down, right? So think of it like this. Every line has its own personal GPS. And to find that GPS, we have two cool tools. So the first tool is called direction cosines. Now, I know, the name sounds a bit heavy, direction cosines. But trust me, it's super simple. We just call them L, M, and N for short. And all they are the cosine values of the angles the line makes with our good old X, Y, and Z axes. That's it, really. That's all there is to it.
Okay, look at this picture. See that line L? See the angle it's making with the x-axis? We call that alpha. With the y-axis, it's beta. And with the z-axis, it's gamma. So, what are our direction cosines L, M, and N? Simple. It's just cos alpha, cos beta, and cos gamma. Easy peasy, right? Okay, now listen very carefully. This next one is your first very important formula for this chapter. Seriously, write it down, take a screenshot, maybe even make it your phone wallpaper. But you have to remember this. L squared plus M squared plus N squared is always equal to 1. This little formula is an absolute lifesaver, trust me. Now, sometimes those direction cosines can be a bit messy, with all the square roots and fractions. So we have their simpler, cooler cousins, direction ratios. We call them A, B, and C. And what are they? They're just any three numbers that are proportional to L, M, and N. It's just like a recipe for making tea. If the ratio is 2 spoons of sugar for 1 spoon of tea, the taste is the same as 4 spoons of sugar for 2 spoons of tea. That's exactly what A, B, and C are. All right, let's try a question. This is a classic, a total exam favorite. You're given 2 points and you need to find the direction cosines. So pause here for a second. Think. What is the very first thing you should do? I'll give you a hint. It involves their simpler cousins. Yes, you find the direction ratios first. Go on, you can do this, give it a try. Okay, did you get it? Let's walk through it together, no worries. Step 1, find the direction ratios. Super easy, just subtract the coordinates. x2 minus x1, y2 minus y1, z2 minus z1. We get 3 minus 2 and 8. Simple. Step 2, find the magnitude. You know how to do this. Square root of a squared plus b squared plus c squared. That gives us root 77. And now for the final magic step. You just divide each direction ratio by that magnitude. And boom, there's your answer. See? The whole trick is just knowing the path from direction ratios to direction cosines. Fantastic. You now know how to find a line's GPS. So what's next? We're going to give that line a full postal address. A unique identity so we can find it anywhere in 3D space. Every line has one, and we're about to learn how to write it. So the first way to write this address is the vector equation. It looks like this. R equals A plus lambda B. Let's break it down. A is just a point that we know is on the line. It's our starting point. B is the direction, the GPS we just learned about. And what's this funny symbol lambda? It's just a slider. As you change it, it just moves you up and down the line. So A gets you on the line, and lambda B lets you travel along the line. This diagram makes it so clear. Look here. We start at the origin and go to point A. That's our vector A. It puts us on the line. Now our line has a direction, right? That's vector B. To get to any other random point P on the line, we just travel along the direction of B for a certain amount, and that amount is lambda. So A plus lambda B gets us to any point P we want. Simple. Now there's another way to write the address, which is the Cartesian equation. It might look different, but it's telling you the exact same story. Here, x1, y1, z1 is just our known point. And look what's in the denominator. A, B, and C are friends, the direction ratios. So it's just 2 different languages, vector and Cartesian, saying the exact same thing. All right, we're making great progress. So now we know about one line.
But what happens when you have two lines? What's the angle between them? Now this is a pet topic for the exam paper setters. They love asking this. So ears open, eyes on the screen.
And this is the magic formula you need. To find the angle theta, this is your key. Now, it looks a little long, I agree. But don't worry, it's actually very simple. The top part is just the dot product of the direction ratios, and the bottom part is just the product of their magnitudes. That's it. Please, please, please note this down. Super, super important. Now, from that big formula, we get two amazing shortcuts. These are your secret weapons for MCQs. Check out this table. If the lines are perpendicular, the entire top part of the formula becomes 0. And if they're parallel, even easier. Their direction ratios will be in proportion. These two conditions will get you some very quick marks, for sure. All right, children, take a deep breath. We are now entering the boss level of 3D geometry, skew lines. I know, this is the topic that gives many students nightmares. But listen to me, this boss only looks scary. Once you have the right weapon, the magic formula, you can defeat it in one shot. So what on earth are skew lines? Look at this picture. They are weird. They are not parallel, but they never meet either. How is that possible? Think about a flyover in a big city. There's one road going straight and another bridge passing right over it. Are they parallel? No. Will they ever crash into each other? No, because they are in different planes. That's exactly what skew lines are. And this is the ultimate weapon, the formula to find the shortest distance d between them. Yes, it has a cross product and a dot product. But don't you worry, if you just follow the steps one by one, this is a guaranteed pukka 5-mark question. You just need to be calm and follow the recipe. So let's put this formula to the test, shall we? Here's an example, right out of your book. We've got two lines. Our mission, find the shortest distance between them. Let's do it. Okay, first rule, don't get scared by the big formula. We'll just break it into a simple checklist. First, identify your A1, B1, A2, and B2. Done. Next, calculate A2 minus A1. Check. Then find the cross product, B1 cross B2. Check. Now, take the dot product of the two things you just found. And for the final step, divide by the magnitude of the cross product. See? It's just a to-do list. And if you follow that checklist calmly and carefully, ta-da! You will get this answer, 10 by root 59. That's it. You've found the shortest distance. You've defeated the boss. The only thing you need is patience and to follow the steps. I know you can do it. Phew, we did it. We covered the whole chapter. But wait, before you go, let's play a little rapid-fire round. A super quick revision of the most important formulas. Ready? This is your quick cheat sheet before the exam. Okay, number 1. Angle between two lines, using direction cosines. What is it? Cos theta equals modulus of L1, L2 plus M1, M2 plus N1, N2. Got it? Good. Next up, the big boss. Shortest distance between skew lines. What's the formula? It's the modulus of the dot product of B1 cross B2 and A2 minus A1, all divided by the magnitude of B1 cross B2. You know this one by heart now, I'm sure. And that's it. We're done. See, this chapter wasn't so scary, was it? My dear children, I am so proud of you for sticking through this. You are going to do wonderfully in your exams. I have full faith in you. You've got this. All the very best. Now go and ace that paper.